Hey friends, it's Mrs. Hazelwood here. Here to teach the second part of this lesson. So we're looking at solving linear equations by multiplying and dividing now. So the property that we're going to use this time is the multiplication property of equality. So that means we're just going to be multiplying both sides by the same value. So in algebra, it looks like A is equal to B. So if A is equal to B, then I know if I multiply one side by C, and I have to multiply the other side by C. This is just multiplication property of equality. So our first example here that we're going to look at is it's a fraction. And what I know when I'm looking at it, I just need to ask myself, what do I know? So where is the variable? So the variable is in the numerator right here. So is where the variable is. So that's what I need to isolate. I need to isolate that variable in the numerator. So therefore, I know it's a division problem. So I'm going to multiply by whatever the numerator is. So the numerator is a -5 because I need that variable to be positive in the end. So then I'm going to multiply both sides here by a -5. So this is the multiplication property of equality. So then I have n is equal to a positive 15 because a -3 times a -15 is a -3 times a -5 is a positive 15. So I'm just going to check it. So I'm going to put my positive 15 where the n is. And then I'm just going to put that negative sign with the 5 is equal to a -3. So we have a positive 15 divided by a -5. So that is a -3. So therefore, it checks. All right, the next property we're going to look at is the division property of equality. So now just by the name, you know that we're going to divide. So, and we're going to divide the same number on each side. So here's our algebra again. If I have A is equal to B, that's my condition. So then what I know here is A divided by C is equal to B divided by C. And one thing that's very important is C cannot be 0. All right, so let's look at our example. So the first thing we need to do is figure out where is our variable. And we know pi is a number, so therefore our variable is our x. So we want to get x by itself. So that's always the first question. Where's the variable? How are we going to isolate x? So that's what we need to do. We need to isolate x. So it's a multiplication problem. So the inverse operation of a multiplication problem is a division. So therefore, I'm going to just divide both sides here by pi. So when I do that, the pi simplifies out. So pi over pi is just 1. So it just simplifies out. And then I have 9 left over. So I'm going to check my work. So I'm going to say 9 pi is equal to, so I'm going to put my 9 in there where the pi is, and that's true. And I'm just going to rewrite it because I can, because it's commutative property of multiplication. So I know 9 pi is equal to 9 pi. All right, let's just do some examples, and we're going to write down the steps now of what we're doing. We're just justifying. All right, so number 5 is it's a multiplication problem. I see right here it's a multiplication problem. So the inverse operation of multiplication, inverse of multiplication is division. So I'm going to divide both sides by 3. So what property I'm using is the division property. Okay, so now I divided both sides by 3. So I have t now is equal to 6. So I'm just simplifying. So I wrote down all my steps. I justified what I was doing. You can pause the video now and do the next 3. Or you can continue to follow along with me. So now what I'm looking at is, we kind of talked in the warm-up that this bar, that fraction means it's division. So I know the inverse of division is multiplication. So I'm going to multiply whatever is in the numerator. I'm going to multiply whatever is in the denominator because the variable is in the numerator, because I need to get the variable by itself. So 4 is in the denominator, so I'm going to multiply both sides by 4. So which property did we use then? Right, so we use the multiplication property. Property of equality. All right, so now this one's just written as a division problem. So what I know I need to do, it's written as a division problem. So C divided by 9. So again, I know the opposite of division is multiplication. I can rewrite this. If you love fractions so much, we can do this. Oh, this is negative. We can do it that way. So those two things mean the same thing. So again, I said I'm going to multiply both sides by 9. So I'm going to use the multiplication property of equality. Oh, I didn't finish that one up there. Okay, I got so excited. So I saw this one over here. So now I know that this simplifies down to 1. So C is equal to a negative 18. And so this is what we did is simplify. And then it's asking me to check. So I'm going to take that negative 18. So negative 18 divided by a negative 9. And that equals 2. So this is true. And negative 18 divided by a negative 9 is 2. Let's go back up and do this one since I left it. All right, so this simplifies down to 1. So I have my S left over. And so 3 times 4 is 12. So this is, I simplified it. So now I'm going to just substitute it back in to check it. So I have 12 divided by 4 is equal to 3. So 12 divided by 4, I know what that is, just what that means, that fraction. So this is 3 is equal to 3. So that checks. All right, so we didn't check this one over here either. So let's go back and check it. So just to make sure we got it right. So 3 times t is 6 is equal to 18. So 3 times 6 is 18. And it checks as well. So far all of them check. So what I did up here is I multiplied negative 9 by both sides. So that's okay. So I multiplied negative 9. So it's a multiplication property of equality, and then I just simplified. All right, our last one here. So we need to ask what's going on with the variable. I am looking at it, and it is a multiplication problem. So the opposite of multiplication is division. So I'm going to use my inverse operation of multiplication. So the inverse operation is division. So I'm going to divide -6 on both sides. And now I have Q is equal to 9. So I use the division property of equality. And then I simplified. So now I just need to check it again. So I'm going to just take my 9 and substitute it back in there. So -6 times 9 is equal to 54. So this is a -54 is equal to this is a -9. See how important it is to check? So the answer here is a -9. So when I went to write it out, that's when I realized I had a mistake. So therefore, we have a -6 is equal is a -9. -6 times -9 has to be a positive 54 because that's what that is asking us for. So this is a positive 54. All right. So therefore, it checks. Okay, I'm going to stop this video and I'm going to upload it, and then I'm going to create another one.